And it says we've gone live 4 minutes into it. And it's saying that's going live in a minute. That's saying that's now live. Best change the quality. Although I don't really need to. Rub them there for now. Grab that while we're waiting to see if any folks join. Join. Pull that out of there. Swap the batteries over. I need to change my chat to live and not top. Live. Sign into chat. Yo, Travis, welcome, mate. Throw that one there. We'll be with you in a second. Just changing the battery over in my meter to the USB meter. Had a good weekend. Figured I'd better show my face for a little while. Not been on for some time. Plug that into there and that into there. Quick look, hopefully, mate. Quick look at the schematics. See if I can not knock everything all over the place, all over the shop. See if I can pinpoint what might be wrong with Rob's. And then, yo, Mr. S, I did think, personally, I think the fault with Rob's 1X board is the Southbridge. That's personally, I think it's Southbridge. Could be wrong, but we're going to have a look. Maybe have a look at Wayne's 1S. I'm not falling off no chair, mate. I'm not falling off no chair. What I need to do is just plug that into there. Then I can minimize that a second, fire that up, turn that on. Let's throw that in voltage mode. Port set. COM3, that should be, and there we have that fired away. Which now means if I go to the scope cam, multimeter, and select that, that should pop up. Multimeter and select that, that should pop up. I'll better put my face there as well. Right, so let's dive straight in. Do we dive straight in with Rob's board first? Danny! Welcome, mate. So, do we dive straight in with the board of Rob's? CJ, welcome, mate. I need coffee. I've just had one, mate. I've just had one. GeForce, welcome. What I need to do, I've got that. Let me just check. Yeah, that's that one set up for the schematics. All good, Chris. Yeah, I'm good, mate. Yeah, thank you very much, yo. Everybody have a good weekend. Right, so back on with this Xbox One X. We have the Codger. Welcome, even if you've just called me a prick. It's all good, mate. It's all good. So, we have had majority of you. No, Wayne, welcome. It's a sea of what? I'm trying. I'm hopefully I'm going to get through this stream without swearing. Might do. Might not. Right. Screw it. Let's crack on. Right. So. I'm not repeating it, Wayne. I'm not repeating it, mate. Oh, sea of blue. Yeah. Sea of blue. I see. Spanners everywhere. Swear anyway, Baldy. No, I'm not swearing, mate. Yo, Gibbo. Welcome, mate. Welcome. Right, so let's get into this before I change my mind and cut you all off. I might do yet, Danny. I might do. We'll see. What were I doing? That's what I was doing. Load that up on there. Let's load you guys onto that. So as you can see, majority of you know the schems got released for most of the Xboxes. Comes in handy, comes in done. Don't come in handy, comes in handy. 1 or 2. Yo, Nigel, welcome. Lee, welcome, mate. Morning, morning. Sure you're in UK. Be afternoon, won't it? So, we are looking at Rob's 1X board. Let the blue, right, the others are watching you. So we are back on with this. Not only are we back on with this, but we've also got this. Yes. Mr. Wayne's Minecraft Xbox One S. Still need board views for what, mate? Mr. Dick Kennedy, welcome, mate. And I figured you might have still been sleeping, bud. So, as we were saying, right, that one there. So we've got this. I can zoom in for you, lovely people. I am currently on. In fact, no, we're on Cactus Fab G, so we're on the one for the Xbox One X. My mind's just going. It's. I'm losing it already. Kyle, welcome, mate. So as we can see, I've been doing a bit of testing through this. Been looking at bits and pieces, trying to make a little bit of a advancement on this 1X board of Rob's. So we have as most of you was aware, let me click that in there, let me fire up some power. So we have 12 volts, which can be checked out there too, just there, 12 volts in the board. We have 5 volts, which can be checked just there, or you can go that side of coil or that side of coil, inductor, whichever way you want to put it. 3.3, we have 3.3, which can be checked that side or that test point. There we do have some standby there actually. 1.8, we'll do it in order. 1.8 volt standby, and we've got 1.1 volt standby. This test point and this test point and this test point, they're all for the switched or south bridge, or whichever way you want to put it. They won't become active until the system's active, or at least until the system is trying. So the way I see it is, we have all our voltages come in. They then go to south bridge. Obviously this is not the south bridge, that's the CPU. Point that out before somebody says that's CPU, idiot. So they go to the south bridge, which is directly under this section, other side of the board. Southbridge then sends out enable signals, one to this and one to this. Also, I believe that was power good A. No, that's power good B. Power good B. Power V. Power G. PB. Enable. Yo, RB, welcome, mate. And it also sends out a power GPA, which I'm assuming is, I don't know if they're in order. So I don't know if A would go before B or B would go before A. One of them comes to this and that, and then the other one goes that, 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 and that. That would be that, 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 and that. I could be wrong though. So, let me dive in to my reasoning that this could be. Yo, Steve B, welcome, mate. I didn't see you pop up there. Let me go through why this. I think this is possibly the South Bridge. Now, I did chat with Mr. Steve B about this before. Mr. Steve B did state that some multimeters may not pick up a signal that's potentially too low to be detected by it, I'm assuming. Advised to get a oscope or an oscilloscope, which I may do at some point. I've just not got one yet. So let's have a look at around this. Point out what I noticed or what I've found out from testing is, so this area just here by the 3.3 volt standby, this is clearly a in signal, so going through basically ins and outs. This is an in signal, so this signal is coming in from elsewhere on the board and then coming into the South Bridge, which is the U2. Yo, David, welcome, mate. And then obviously your outs are your outgoing data, information, power lines, whichever way you want to put it, from your South Bridge to elsewhere on the board, whether it be a IC or resistors or down to the front panel connector or somewhere such as that. So obviously the eject and the power switch, and which would be that power switch, eject, bind, so that would be for your controller sync. These are all incoming signals, so when you push the switch on the front panel, it should pull this line to ground, which then tells the South Bridge that you're wanting to boot the system. Again, I could be wrong in my thinking. I'm sure somebody will jump on comments and tell me I'm wrong. Hopefully somebody would jump on comments and tell me I was wrong. So, as I was saying, now what I don't get is, and I'm at first I figured the P0, P1, P2, P3, P4 may have been some kind of sequence, but it's, from what I gather, it's not a sequence of the way these consoles boot. But we've got 3.3 volt standby coming in to the Southbridge here, but yeah, this particular line here, which is voltage whatever, power good, PC enable line, we get nothing going out from that. Don't believe we get, no, we must get as VREG 3.3, or we might not do, because that's not standby, so it's just a 3.3. so because it's not standby, it is the switch on. So when you boot the system, it will then throw the signal out from that to enable the voltage regulator for the 3.3 Southbridge SP, whichever way you want to call it. So we don't actually know if we're going to get that signal yet. This one here, which is voltage regulator, I'm assuming reg stands for regulator. 5.0 power good. We are receiving that signal, which is the in signal. We're receiving that in. Back into the system. VREG V5.0 enable, if I remember rightly, I think we receive it, it's sending that out, but we are not getting that signal, or can I do it like that? No, I can't. We are not getting that signal on the out. Quick catch up on chat. Yo, Paul, I can't remember if I said hello to you. RB King, Paul Willis, that is. And then Paul Baxter, welcome. So, the way I do this is, let's say we want to look for this. We want to look to see if this is being issued by the Southbridge. Easy peasy. There's two ways you can do it. If you follow this line down here, we've got a DB8, which is a test point. Similar to a test point. Can I remember where DB8 was? Which I shall. Let's go over it first. DB8 is on the other side of the board, and we are over by this section just here. Grab the scope cam, raise that way up, and there we have it. As you can see, I've already been prodding and messing. Again, we got no signal to that from there, but that's one place you can test, and it states that on the schematics, states there DB8, wrong one, just there. Oh, we can follow it along. We've got as out signal, or as information that tells us it's an output rather than an input. And then with these numbers at side of this here are page numbers. So this particular section here, I'll just copy that for the next one. So this line here also shows up on page 54 and it shows up on page 64. The other way we can do that or find that out is by clicking on our search and just paste whatever you've copied into there, click the old enter, and we also get, it'll show us that it's found one of three being the maximum. We can then go, just remember that, it'll show it there. If you use the search option, it will show it there, it won't wipe that off. So we can then click on next, which will then take us to the next page. We are on page 54, and this is our signal here, and this is an input signal. So we've now moved over to U57, which if I quickly switch over, but this is an input, so this comes, it then comes to the enable line for this chip. So should our south bridge decide it's going to send data down this line, it then comes to this one, which is having to change screens. U57 is this chip. So this is one of the power managements, or the pulse width modulator, or the phase generator, whatever you want to call it. I know phase generator's wrong. Oh well, tongue tied and all that caboodle. So this then also tells us what pin this power good enable signal comes to, which I'm going to knock that power off there for the minute, which is pin 18 of this chip. We can nip under the scope. Alright, quick. And we can drop that into a little bit of focus for you. This is a 40 pin chip. So we've 10 pins on each side. We want pin 18, so we've 10 that side, 10 this side, minus 2, which would give us pin 18, which would be that one there. So that one there is our enable signal. We are on voltage mode. I would assume that this would send out, or this would receive in at least 1.1 volt. I can just give a bit of power to that. We are currently reading 370 millivolts, 390. And then it's dropped back down, so on and so forth. I would assume that the enable signal to that chip would be a lot more. Let me go back over to that. So that's another way of doing it. Just simply search in the find, and then from there again we can go to next, which then takes us to U27, which would be the voltage regulator for SOCFI. Not sure what SOCFI is. Well, I know what SOC is. SOC is system on chip. Not quite sure what PHY means. Could be physical system on chip, or system on chip physical. We don't know. But again, it's an input signal. So then if we then go back to next. Now, I'll point out where U27 is right quick on the overhead. U27 is this one. So basically when Southbridge sends out its signal, enabling signal, both these should enable at pretty much the same time. If we then go back to the schematics, we can then click next again, and it will just take us back to where we basically began, which was that one there. And again, it's the same for any other signal. So if just a quick thing on that, if we wanted to jump to there, let's say, which would be system on chip power OK, which we may not be getting, we can control and copy that, and then we can paste that into there. We click OK, and there is only one of one. One of one is a output. So one of one being that specific search. If we remove the R, so it then basically just be in this section. We then see in the top we've found, we're on one of 5. We look there, we've got 1454 and page 75. So one of those is going to have 2 wordings on. Wordings, if that's the right choice of a phrase to use. System on chip physical switch, possibly AD. I'm not sure, mate. Could be. I have absolutely no idea. If it is, I will indeed try to remember that though. Right, yeah, so when I said there were 2, there were going to be 2. There is particularly there's this section there before the art, and then there's the section there after the resistor. But again, we can go out. We've then got U57, which was the same IC of which I showed last time. We had the enable line there, so that was the enable line we looked at last time. That there is an input, it's an output from the system on chip. Now I don't recall checking that one. I may have done. Let's have a look and check. Right, quick. So we want pin 27. Pin 27 of the U57 IC. Eeny, meeny, miny, mo. Too far. We are there. So 27, we've got 10, 20, 30, minus 3, of course. I'll put my let's see where that one goes to. So 27 would be that one there. That one goes to that resistor just there. Apologies on the jumping around. Do we get anything there? Not really. 6.5 millivolts. So we're not really getting that signal data from, again, the system on chip. The system on chip, I believe, is going to be the Southbridge, simply because if you go to wrong chuffing screen, Chris, if you go to, let's say, 36, this is all part of the system on chip. And U2 is of course the Southbridge. U1 would be the CPU, so on and so forth. I'm assuming. So we don't see most of the output signals from the Southbridge. There's no saying that it's not something else along the lines that's not, or something that's not being pushed to Southbridge in order for Southbridge to activate. I'm not quite sure. Don't think anything really enables Southbridge. Southbridge would just be for communication, possibly, almost like a spaghetti junction, whichever way you want to put it. I'll have little roundabouts in, you know, for traffic. I'm assuming, could be wrong, Could just have had a brain fart moment there and explain that completely and utterly. Terrible. And it's pretty much the same. We'll go over Wayne's board on the 1S schematics pretty quick, but the overall see, I'm not really big up on just randomly changing ICs, so for me I've got to try and justify removing a component and changing it. Now Mr. Steve B did tell me that the first port of call was U57, I think, if memory serves me right. I changed U57 because there were I wasn't seeing a enable signal on it. I also changed U64 because there were no enable signal, so on and so forth. But I did chase down lines and so on and so forth, seeing that the enable line went to other components too, but no joy. So the other thing to do would be to change the south bridge on that one, on Rob's 1X board, which is a little bit more awkward than doing Wayne's 1S board, especially on the preheater. And it's a little bit more awkward because it's a off shape, doesn't quite fit the preheater, and I haven't yet adapted mine. So then we jump on to Wayne's, right, quick, and go over this. This, of course, is Wayne's heads going, Xbox One S board. This was power on, power off. So, of course, me being me, I just sit and play around. Ding, 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 ding. It's almost like a little lullaby. Lullaby. So I did some digging about on that one too. Let me know if you're bored yet. In fact, we may need that one in there, actually. So we will plug that back in. We'll take a probe. We are getting all signals. last time we checked, we were getting, don't like the look of how this cap is. But last time we checked, we was getting voltage reference from this was trying to kick in. We changed a few things. For the viewers with the OCD, you guys probably remember the discoloured caps and things up this area here. I went and changed majority of that area for you people, with probably the exception of that. Although I did change that cap, it's just must have been slightly burnt looking. And this had some kind of liquid damage. I think Wayne changed that FET there. Yes, Steve, of course you can, mate. Let me just knock that down a minute, Steve B, while I find Steve B. Of course, yes, because Steve won't be able to drop links if he needs to. Where was we? So I did some digging on this board. Now, if I draw your attention to that, let me knock that off. Alright, quick. So, if I draw your attention to this, we are still in voltage mode on the meter. We've got the 12 volt test point right there, just to the left, or right should I say, not left. Now, the capacitors round here don't look cracking either, and this is by the HDMI out. So in sense we should have 5 volts on pin 18, and we have nothing. Diddly squat. It's also not short. Comes in there, and I believe it's supplied by that capacitor, or that line. Is that even a capacitor? because it looks mighty black. There's that one, but we do have 5 volts on there, so I'm assuming that capacitor's good. 5 volts comes into this, and then it runs to that, and that then should become 5 volts. Yo Mark, welcome mate. Steve, you should now be a moderator, mate. Sorry, my apologies. Should have informed you that I'd changed that. So, as I was going on and boring you a lot, we should have 5 volts here, but we don't have 5 volts at this section here. So then you've got to kind of think, well, why do you not have 5 volts at that section there? And again, with like most components, that ESD IC has a enable line. So we'll go here, and we'll go there, and we'll go to there. Yes, do that, I'm not bothered. Let's search, and let's go for, well, there's only one HDMI out, so let's go for HDMI out. There's only one page for HDMI out, my apologies, 1 page. So we want the page that specifically is for HDMI out. We'll knock that off for now. Zoom in a little bit. So SN75DP159, SN75DP159. That'll be just the breaking down of what that IC does in terms of data and whatnot. We want this one in particular, which is the ESD IC. And this indeed has a enable input line, as we can see. So this is an input. It comes to this component, and then this so that'll receive data. It'll receive voltage. It'll receive some kind of signal from wherever is pre this page. So we'll have a look in a second to where this comes from. But basically this isn't receiving, it's enable. So this chip isn't enabling. So because it's not enabling, we can't get our 5 volt out to pin 18, which comes up here, because it's not turning on. My apologies for rambling as well. Just give me a nudge in chat if I'm starting to chew somebody's ear off. So looking at this, we can check to see if that enable line is valid, or not necessarily valid, but if it's being sent or issued or whatever through this resistor here, which is R8B11. Wrong. Next screen down, Chris. Not the top screen, but the next screen. So R8B11, which is just there. This side goes off to ground, and this side carries our enable signal. And as we can see, if I now power this board on, we do not receive any enable whatsoever. So this IC is not booting. It ain't turning on. So we then go back to this. Turn that off for now. Slide my keyboard out, and then we can then copy. Well, that's what we're just gonna go through, Lee. So I can copy this information here from that section of the schematic. We can paste it into there. We can hit enter, and we've found one of two. So, as we already know from the previous brief crap description of running through a schematic or whatever, which could be done completely wrong by me, of course. We already know that there's only one other place this line pops up, or this information for this line pops up, which is on page 26. So we can either go directly to page 26 through that way, page 26 there. We can go through our little find box. We'll go that way. And as you can see, we have that information just there, which is the out signal. So typically there is no other resistors in that area. So there's no other. So between this page and this page, we've simply just got that one resistor. We have an FT2N1, which I believe is again another test point. So we only have that other one resistor on that line. Yeah. So again, we're on to this, which is U4D2. U4D2 indeed is Southbridge. But I did find something else out, and I'm trying to remember what it was. Bearing in mind this was, I looked at this last week, one of the days, last week maybe, last weekend. I can actually quickly find out. Yo, CFQ, welcome mate. Is the Southbridge now outputting any other signals? Yes. Yes. Believe the south bridge outputs a signal from this to this, which then controls the HDD power and the so it'd be that one and that one, idiot, for the HDD, and then that one and that one for the disk drive. I'm thinking if it's outputting other signals, then it could just be a solder ball issue. It could. But, and I'm trying to think of how I then went down a different route. How can I find out? I'm thinking donor and be done with it. Why? Why donor it? Well, let's see. Well, we have 1 Rebald, Southbridge. Specifically from my Xbox One X board that I probably use on Rob's, and then we have another Rebald Southbridge that I sat and reballed this morning. They are both actually the same Southbridge ICs, but what I will say is, and there is an extent of understanding to Wayne's comment of, I'm thinking donor the board I'm not doing it and be done with it. There is reasoning to that comment. Is I've pulled this from an Xbox One S board. Funnily enough, that Xbox One S board didn't work. It was on the donor pile. Could have been power on, power off, for all I know. Can't remember. But it just means that if I put that Southbridge chip onto Wayne's board, it will either make it worse, not change anything, or it'll fix it. The downside to that is, if it doesn't change anything, if this is still a power on, power off, it could still be the Southbridge. And we just would never know if the Southbridge that I put on was faulty. That could be the self and same reason to why the other board was a power on, power off, let's say, a no power, whatever else. But I will quickly go over. Yo, Glyn, welcome, mate. If I've not said hello already, is the Southbridge getting all the voltages and enable signals it needs though? And this I'm not quite sure yet, Lee. One, I only quickly glanced at this board of Wayne's. I was particularly testing around the fan area, because I wasn't keen on how that capacitor looked. Yeah, that capacitor's not showing a short, and it's also what it did it show voltage? Did it show voltage? Is that how I got to my conclusion of checking that? Not sure. Let's have a look. Let's have a look. Drop that in there. Eeny, meeny, miny, mo. Which one was yow? It was that one. So square should be positive. Wrong one, idiot. Square should be positive. You guys can't see where I am prodding and poking. So no, we didn't get voltage at that capacitor either. Did I get voltage when trying to boot? I can't remember. Let's plug that on the let's put that into the and let's go on the same. Why did that just not even do that its own tone? But we essentially we do try and get it. It does try and throw voltage on that capacitor at 20 volts. Why are we not getting why as all of a sudden that changed? Speaker tones, why is it not giving us as little chime? Oh, I don't know. It's still power on off. Anyway. Check-in voltage and enables is a tall order for an SMC. It is, mate. Different front board? No. Same front board I've just had plugged in, mate. It is the same one I've just had plugged in. It is a bit of a tall order. And as we can see from here, we have pages upon pages upon pages. If I drop that out of that, we was on that page previously, so that was one of the lines that we came back to, which was that one there. That's the output signal for the ESD enable. So yeah, we go up a page. We've also got parts in there, which is input, output. That's for the SATA lines. So it don't look like there's going to be any enable signals on that section there. I'm thinking I'm thinking a PMIC in front of the SMC could be not sending voltage plus R enable. It is possible, mate. That's what I was trying to remember how I ended up down. And that could be the self and same for Rob's 1X. And as you'll say, it's gonna be a bit of a tall order. Don't think it'll be. I don't think it'll be memory, but obviously from that you've GFX core. These are all voltage lines, not necessarily, although saying that, no, ignore me, because U7E1 is the CPU. So the CPU is going to be the system on chip anyway. But I don't think, no, because it's got to be more. I don't even know why I've ended up on system on chip from SMC, which would be Southbridge. Rambling to myself, U4D2 is there. Bye. USB-C. USB-C, man. So, how did I get to that? Where did I get to that? Let me see. Let's go for Q. No. Let's go for U9E1. U9E1. Right. So let's. Let me quickly see if I can dig down there. So that would be pin 4. Pin 4 is glasses back on, or else I can't see. VCC. So pin 4 of that FET drivers, of the FET drivers, which is here. Somehow I ended up on the line 4 that. Wasn't ready. Should have had everything ready. No, there's only one of them. Which was pin 4. Yeah, pin 4 for that one. That's why. So it must have just have been that. And there we have it. So the way I'd come onto this was, I think I'd gone down the route of checking areas, and I'd got onto the GFX core or the graphics core, or whichever way you want to look at that one as being. And there is 48. Majority of them are all on this page, which is a pain in the ass. But there's a possibility that that wasn't switching. Can't get tobacco for £5 here. £5. Where's here? Although I don't smoke it anymore. I've moved on to the vape, and only on the vape. So the decision was, do I swap Southbridge on the off chance of it being Southbridge, or do I hunt further, in which case it'll be a short stream of 1 hour 17 minutes. 1 hour 17 minutes, and I've done nothing at all. Nothing at all, other than bore you all with some smooth talking. So, question to you all: do we swap Southbridge? Lee says swap it. Thought somebody might. In which case it's a bit awkward for me as well, because it pain in the ass picking Southbridge up with. Pain in the ass picking Southbridge up with a pair of tweezers. My son has just realised my doorbell can be moved. Oh, mate. I'm not sure, Nigel. It might have done, yeah, mate. But power on off, or beep on beep off, can literally be, well, it can literally be anything on the board. And if we go down the route of what I previously did or previously changed, we looked at that, we changed that, FET, we changed that, I think. I went back after stream and changed majority of components that looked dull, burnt, as a lot of people say, which, by the way, is over here. Not sure what that is. I even changed the pulse width modulator, 4205, that's 4205. and we got no change. Blue tack on a pencil. I'd like to see a bit more fault finding just in case it's something easier. And then the reward will be epic. A BGA swap is good, but a stab in the dark type of fix. Yes, I agree, mate. I agree on the stab in the dark type of fix. I would much prefer if I'd have had a... Then again, I've never used one before, so not forced to get the hang of it straight away. But I probably would have preferred using a oscilloscope, or O-scope, as majority of people might call it, an O-scope. Oh, not no. Oh. What was that PMIC that was changed to fix beep? To fix beep on off. I can't remember. So yes, I agree. As well as scope. I agree with Lee. Mr. Bridger, welcome, mate. I agree with Lee. Ideally, further testing, further checks, further diagnostics is, or would be ideal. Come over to mine for a day, Chris. I teach you how to use an oscilloscope. I would, mate, but you're like 2 hours away. And I ain't yet bought one. I need to buy one first. Danny, you mean Joey's NCP 4205. Changed NCP 4205 on this board. Made 0 difference. So that NCP 4205 is likely good. Bob that in there for now. See, I understand where Steve comes from. Steve did say that some of the enable lines may only be like some millivolts, which I do have 2 meters. I have my infrarider, which doesn't necessarily, it shows me millivolts, but it doesn't specifically have a little selection for millivolts. And then I have this meter, which again is just a cheap meter, 30 odd pound. I think it was from Farnell, which was an original one I bought. To find it didn't come with the Bluetooth adapter. And then I would have needed to have bought the Bluetooth for a Owen. But yes, I fully agree with Lee. Possibly more testing to do before we can go just changing the Southbridge. Remind me, this one has voltage rails, but it's dead or beep on, beep off. Yes, this one is beep on, beep off, Ross. This one was the Minecraft edition from Wayne. Changed a boatload of components from there that looked all mucky and crap last time. They are sat there in the corner. We don't have an enable signal coming up to from Southbridge to the ESD protection IC on HDMI out. So with an oscilloscope you can check the enable lines are alive. An oscilloscope will show you pretty much yes. So I gather let's say the enable signal runs at 0.5 millivolts. My multimeter may not go as low as 0.5 millivolts, yet a oscilloscope isn't necessarily going to show you it as the voltage. You're not necessarily going to just hunt round for a voltage, but you would be able to visibly see from the oscilloscope screen whether there's any activity on that line, I believe. Again, I've not really used an oscilloscope as such. Never used probes and stuff on. Yes, square wave, whichever. But yeah. So I'm assuming that that's how it would work. And I'm assuming lightly. So we go back to the question of. I agree. Ideally, there should be more checks. Delve a little deeper. But we also have to bear in mind that we have as voltage rails. We have as voltage rails. Could be something on a return for a switched data line. It could simply be one of the one of the FET gate drivers, or whichever way. I think it went down all being part of the same signal line. Did we have fan on this? Yes, Ross. Depends on chip. Some require voltage. Some. I see. I see. But you'd still see both, would you not? On a smelloscope. You'd see pulse width and voltage. No. So back to the question. Because I don't have an oscilloscope. There's no necessary signs of me getting an oscilloscope in the next few days. Maybe, don't know, because I've never had one. So I've particularly been looking at a 4-channel MOSFET. 4-channel MOSFET. I'm not swearing. We're not doing it. We're not going there. 4-channel oscilloscope. 200 megahertz frequency. So I'm assuming it'll do anything up to 200 megahertz frequency. Possibly 50 megahertz would be ample for this type of particular work. Could be wrong. No idea. But a 4-channel for future reasons, that way when I first, so to use an example, when I first bought my bench power supply, I bought a singular bench power supply, so it only had one output. And then of course you plug it in and you think to yourself, well, yeah, it'd be nice if I could inject power there as well at the same time. And you know, sometimes there's cause to have and not need than there is to need and not have. No. So, of course, if we don't go down the route of just pulling off the south bridge and reflowing another one on, knowing the other one could be faulty, just the same, and then you end up doing more testing anyway, is it really worth just pulling it off? Rob's 1X board is a little bit more awkward, as I was saying. It done. I could go down the route of pulling that off, but it ain't gonna sit on the preheater. I bought a preheater, which comes in handy because, well, let's just say once it's temperature, these Southbridge come off in about 30 seconds. Very quick. Takes probably about 9 minutes maybe for the preheater to hit temperature. So 10 minutes and your Southbridge is almost off. Roughly. Don't hold me to that. So do we wait? Do we pick up a smelly scope and then look further into it when I've learned very quickly bog basic checking of or with a smelly scope? What's it gonna be? I'm not, as I say, I'm not keen on just hot swapping, components. It drives me absolutely crazy. Don't know if there's many others the same, but kind of keeps you awake at night, you know. Well, what caused that to fail, or why this, why that? We have seen Southbridge failures before, out of nowhere, random failures. There was that board of Nigel's, although that did show a short on one of the voltage lines. But what's the intake on a Southbridge gonna be? Enable wise, we've got 5 volt in there, which is a power good signal. I'm assuming does 12 volt run through. Chris, I'll do a stream showing how to use a scope in what, mate? Should get about 1 volt on them. 1 volt on what, mate? 1 volt on. Do you get any pulse of voltage on when you hit the power button? Well, let's have a look. I believe so, mate, actually. Let's have a look. If memory serves me correct, then we do, yes. But this is much similar to, and this is the other thing. Basic, yeah. Yes, Steve, that'd be awesome, mate. As I say, I've not got one yet, and I can't see me getting one in the next day or two, so there's no rush for my account. There should be test points around the SMC for voltage and enable lines. Yes, there will be, mate. Let's just quickly let me just pin that to there. So what I was going to say is what's interesting is on Rob's 1X board, pin 5 of the front panel connector actually shows 3.3 volts, I think it is, when the front panel is connected. Throw that there. So we've got, quickly go over these, we've got 12 volts, we've got 5 volts, we've got 3.3 standby, yeah, we've got 1.8, we've got 1.1, that and that for the switched NB core, CPU core and GFX core. Ross says should get about 1 volt on them. So we've got NB core here. 1 volt, flashed up. CPU core 1.3 volts, and GFX core, what was that, almost 1 volt. No. And nope. And nope. Nope, 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 nope. That's millivolts. Millivolts. So we're not getting any. We are getting something. Because we're on 0. So we are receiving something to that. But yeah, flashed up 1 volt. Flashed up 1 volt. There should be test points around the SMC for voltage lines and for voltages and enable signals. Yes, indeed, there should. So, if we... Yeah, it did, mate, and then consequently thereafter it was in the millivolts. I may have had may not have had a good connection. No, may not have had a good point on that, but we do hit 1 point, and then consequently thereafter we don't even hit 1 volt. We do initially hit 1 volt. MEMIO should be about 1.8, but that's going up to 3 point something. Some meters have a hold button if some meters have trouble seeing it if it's so quick. Yeah, again, I think a smelloscope. Lee's got me saying a smelloscope. I think a smelloscope would come in handy for seeing that, with it being quicker. Can you not get a meter with millivolts? I can, but in fact I have one, but there'll still be a level of how accurate that meter or that particular meter is being tested to. So as an example, Steve B's meter, he has it's either a 5.5 digit or a 6.5 digit meter. So it'll be calibrated to a much more professional level. We're gonna go for professional level. So mine, I don't specifically do it on a professional level. As such, so I don't have or didn't have the use of a very, very accurate meter. The meter I use typically accurate enough. If an enable signal requires 1.8 volts, then I'd see a 1.8 volt line with my meter, so it typically does for what I need it to do. I have a logic probe gathering dust if you want it, Chris. I think it only shows if a line high or low. I don't know how I'd go about using one of them, mate. I really don't. So, if we go back onto this, what was... yo, Michael, by the way. Jaden, welcome. Gents, welcome indeed to this crap show. So far, we're an hour and 45 minutes in. We've done absolutely nothing. And, plus side is I've not yet swore. I don't think anyway. Sure somebody will tell me if I have. And then I'll have to bite my tongue even more. Make it better for children. Mr. Bridger Ross says V-Fuse 0.8 volts on power up. V-Fuse is there. V-Fuse is there. We sees nothing on V-Fuse. Well, we see bits and pieces. Again, it might be the... If that's on a working one, it may be... Pardon, that we got 0.8 volts then, I think, or something. It may be that again, it's too quick to be seen. Obviously, we're gonna get something on the switched 3.3. We get switched 1.8 or Southbridge 1.8, Southbridge 1.1. VBAT, we have our 1.8 on VBAT. So typically all our voltage lines are present. Well, that one that didn't display that voltage there straight away, and then it did at some point. But we need to look into, we have no, and then we jump up to 1.8 when we've attempted to turn it on. No stunts today, Michael. No stunts today, mate. So, the way I see it is, some point, would it work like that? No, not necessarily. Not necessarily, Chris. It won't necessarily work like that. My thinking just then was that 5 volt enable would go out, then it would receive, Southbridge would receive a power good signal back in from the 5 volt step down converter or regulator, whichever way you want to put it. So I'm not entirely sure. I'm not entirely sure which input we should specifically be looking for. before. See, we're not going to get anything such as data or the clock, because I'm assuming they'll really only appear on a running system. So if we were to look at the clock and data lines, we're going to assume there's something wrong with them anyway. Just replace the board and charge the customer. Well, you could do, but there's no fun in that, Glenn. Should I say fun or should I say punishment? Luckily this in customers. This is one that Wayne looked at, one that Wayne got. So I don't mind. I honestly don't mind just sitting here and playing with this board to kind of try and work out what's gone wrong. Not necessarily, Gibbo. Not necessarily, mate. Not in it for the fix. I'm more in it for the knowledge of what failed. So we could determine what is wrong with this board, and yeah, we might fix it, but it's more working out what went wrong for me. I think having an explanation. So it might be that I can't remember if Wayne changed it. I think Wayne changed it, actually. I think that was one of the first things he changed because he'd had the same or seen the same fault before, which I think Wayne changed the Ethernet control IC. I honestly can't remember, but it's knowing what possibly caused it to fail as opposed to the fix. So looking more along these lines, because we don't get any enable signal coming out from here, do we specifically look at this section, which is more the point? See, I'm not like way up on schematic reading. I can kind of follow on, but I'm not 100% confident on reading one. That there is going to be an out. We've got there a VREG 1.1 active enable. So that's 1.1. So that's 1.1. So we can jump to that. We can jump on that and see what's what. Yo, welcome, mate. Welcome. Not necessarily for future repairs, not necessarily, because that's the downside. The downside of the power on, power off, and in some certain cases, the absolute diddly squat no power is it can literally be anything on the board. I mean the RAM IC can cause power on, power off. Any single one of the RAM modules or if you want to call them modules anyway. You know, just one of them can cause power on, power off. The SN75DP159 possibly could cause power on, power off, but I would specifically assume that there'd be a short visible if something like that was causing a power on, power off. So that we've just looked at there, VREG 1.1 active enable, runs through resistor 9D15, then goes on to page 54, 57. I'm assuming it will go, that specific one, I'm assuming will go to this component here, which is obviously the Southbridge 1.1. And I'm gonna say that on that specific line we're gonna have an active enable line coming out of that, just for simple reason that it attempts to turn on. R9, let's look for R9 D15, so that's resistor 9, and we are in location D15-ish. R5, we want R9, R9. Do we want to be over there, or do we want to be over here? We want to be over here. So we have here R9D15. Switch to the scope cam. We have one side of R9D15 going to ground. That's a 10K home. Yes, I am still live, Mr. Coder. R9D15 is right there. So one side is going to go to ground. We can, I'm assuming it will be this side. No, it's not. It be that side. It be that side. Yeah, that cap's not great, but it's doing its job. So we then want back on voltage mode, and we want this side of the resistor. Bang, bang. We want some voltage applying. We did just get a little bit of a signal there. Cable. Power on. And we do indeed get a enable of 6 volts it was showing. That I'm assuming is my meter. My meter tends to go, so let's say if something's 12 volts, it might jump to 24 volts first, or 20 volts, and then settles back down. So I'm assuming the 6 volt enable line for that, which is there, would have dropped down to around 3 volts ish, give or take. I'm assuming could be too much. I suppose we could test that in unhook that. Let's just unhook that and let's go for the ohms mode. It should have been 10k. Wrong resistor. You was going for the, and indeed we have 9.92k. So that is about right. The Xbox schematics finally being used in a video wall. Well, maybe not being used, possibly abused. But let's start over. We have another input, so we could basically concentrate on all inputs. Now, if we're getting all input lines, then surely there must be some kind of breakdown within the south bridge. Bear in mind that these things, they can still fail open, so typically because there's no short doesn't mean that the data's getting through. But let's have a look at this one. This is HDMI RX DDC 5 volts enable, I'm assuming. E would be enable, although there's no N, so possibly not an enable. But let's have a look at that. So we should be able to see on resistor 6T5. Oh, super smashing great. Because you all know where T5 is, don't you? Hey, bagel. T5 is going to be on the back side. Resistor 6 T5, and we are looking for resistor 6. Can I pick it up under my scope? Let's have a look. We want, actually, R6T5 sounds familiar. Have I already checked that and we didn't get anything in? Let's have a look. Let's see if I can so what were we after? R6T5, R6T5. R5T6. R5T6. We don't want R5T6. We want R6T5. Let me have a quick gander, see if I can spot it with my eye. And I can indeed. So, we're there. We want to go over here. Have I gone too far? Have I gone too far? God damn it. Where did I see you? About there somewhere. R6T5. R6T5 is there. And I've not prodded about at that one yet. So it's a 0 ohm resistor, so I'm assuming this side here will go into the south bridge. Do we see anything? Do I need to attempt to turn that on before we might see anything? No, we see nothing. We see nothing, just in case of bad resistor. Do we see anything at that side? We're in chuffing ohms mode, Chris. Idiot. Voltage mode. We still don't see anything anyway. Voltage mode. And now so nothing either side of that. So that's an input. That's an input. So while we have that input, not quite sure what it would be for, but while we have it, let's just go and pinch that. Control and C. Pop that up. Control and B. Hit ye old enter. 1 of 4. 2 of which are on this page. The only other page is 37, so I could have just jumped to page 37. And then we have this one here. Yes, of course. That's why we're not going to see a signal on that line. That comes from the HDMI in, runs through the 5 volt in. So typically when you plug in a HDMI lead, the TV will more than likely send 5 volts down the line. This IC would pick it up, and then from there it would head off over to the south bridge somewhere, and it is indeed a buy signal. So yeah, we're not necessarily going to see that one. 26. Let's start back over here. Yeah, HDMI detection, Ross. Yow or not wrong, Squire. DPO HPD. HPD is going to be hot plug detect. That I'm going to say that input is irrelevant for our inquiries or our looking into it. So we then have TD TDOR. Don't know what TDOR is. Two input signals. One is TDO. What would TDO be? On that page there is suck power. Okay, worth looking at. Yeah, I don't think we're getting that, mate. Which was that one there, was it? But that's an output signal. So we at this stage we don't see that. We don't see that, do we? Did I go on one of the resistors and check? Did I? Have I done that this evening? I possibly don't think so. But that's an output signal. We were looking to see if we were missing any input. J tag. Does that go off to J tag? Is that what Mr. B is saying? I'm assuming it'll go to other places as well, won't it? That anyway. But if we're not getting... But here's the thing, and Lee, which is just back from the school run. No, we've not fixed it yet, mate. Isn't wrong, I guess. Ideally check the inputs first. And then if all inputs are active, or at least trying, then check outputs, I'm assuming. Yeah, it's that's an output, mate. I mean, I can check it while we're here. It doesn't take 2 minutes. Mr. Steve B's trying to phone me. R5T29, so that's resistor 5, and we want T29, which is over by where we was anyway. Mr. Steve B has sent a voice message. Momentarily mute while I play this, in case he's cursing and swearing off at me. 2 ticks. So right, so TDO. Mr. Steve B states TDO will be for the JTAG portion of it.
TDO and associated pins are for JTAG. That is for debug and loading software onto the chip directly. They won't be used, not for general running.
So TDO will be TD out and TDI will be TD in. Although TDI also has a TD out, and I've just confused myself. Not. Kind of. Almost. Where were we? R5T9. UR is the Yeah, possibly. Now, my argument with UART is, I don't think I've ever seen anybody use UART on a system that powers on and then directly after powers off. I've only ever heard it being used for likes of PlayStation 4 long pulsing blood, which just continues to pulse, so which means the power's there. So my argument is I'm not convinced the UART would specifically work on a Xbox One board that will power on, power off, because it may not stay active long enough in order to pull all the information. I could be wrong though. You know, I could be wrong. We'd just have to wait and see, I guess. Sure, some tip-top, bright, spark, brainy bunch, 1,000,000,000% times better than me will come up with a damn good plan. Almost, we're in there, almost. Unless you could maybe inject voltage to the IC to pull the logs. The problem is you're having to inject, would you not have to inject voltage into all of the ICs at the same time? Depending on where the fault was, if that makes sense. Possibly might not make sense to me, but no. What's that? Is that just a bit of crap? A bit of crud. Eeny, meeny, miny, mo. Those. Yeah, possibly. I'm not sure. It may be possible. It's just I'm not nearly capable of working out UART. It's something I've never ever looked at doing. 2 ticks. Yeah. So Mr. Steve B kind of confirmed that on, power off, UART doesn't run. Can't relay everything he said because my memory's shot to, yeah, rubbish. I'm not capable, just got a load of ideas with no time to execute them. I mean, yeah, it's not everybody has time, mate. I probably would have time to be able to kind of look at things like that, but there's only 2 problems with it. One, I am nowhere near smart enough to work something out like that without having the aid of some other that has previously done it or anything like that. And 2, yeah, I can't even remember what section we were at. R5T29. R5T29. So I need an R5T29. It's somewhere on the back, underneath South Bridge. R5T29. That one back going, wasn't it? So R5T29. It's a 0 ohm resistor. It's a output resistor. And we also may as well, while we're there, look at R5T31, so 29 and 31. Wrong screen, and drop onto that one. Get a quick rough idea of where they were. And there we go. So we've T29 we've got T39, T38, T29, so that'll be T39, T38, which is empty, and T29, which is one that we want. Just dig my thing in there. We should see something there. And we don't see anything, but that's an output. We can go the other side of that as well. Sure, I've been prodding there before. We see diddly squat, which is a output, but if the input, if something on the input lines isn't getting through to enable Southbridge at that particular point. But what do we call that particular point? Which is what I was saying before. So this out isn't getting out. Sock reset. I didn't look at that neither, did I? Which was R5T31. R5T31 is R5T31. At that point, no, is it? Almost so. R5T31 is there on the board. Yes, it is, or at least should be. Doesn't say it's empty. On my 5-second beep on off, I get pulsing between 0.9 and 1.8 volts on R5T29. Yeah, so your Southbridge is sending out that signal. So essentially what we're saying there is that your Southbridge is being enabled. Your CPU gets warm. How long does it stay on for? Is it 5 seconds? 5 seconds, possibly something around the RAM or Northbridge, possibly. Might not be. I might just be talking out my ass. Anyway, But yeah, so basically because you're getting the output from there, and then typically your south bridge is enabling. It's possible that the south bridge isn't enabling on this one if it's not receiving one of the input signals. Possibly. Don't know. R5T31, R5T31, yeah, but that kind of says your south bridge isn't powering up. Yeah, that's the argument, mate. That's why we were mainly looking for inputs. It could, I mean, essentially, it could be powering up. It might just not be sending out certain ones, but yeah, more than likely it's not powering up. So because we're getting more of the output sectors, would it be right to use sectors? So because we're getting more of the outputs that aren't enabling or aren't running, then it is likely that the south bridge isn't booting. So but yeah, I don't know. It could still be. I mean, it could still be. It could still be just a dead south bridge. Possibly. But unless it's failed short, so unless it's a line that's gone short to ground, that's when the system's trying to turn on, it's then hitting that point and it's saying no, you've got no chance, mate, I've hit a brick wall, and then deciding to shut off because of a short. You'd think that short, if we can narrow it down further, you'd think that short will become visible to us some way or another, testing with the meter and whatnot. Again, the biggest thing is it depends on how long you want to spend on a particular board. I mean, we're 2.5 hours into it. We're not really any further on, barring a few outputs that aren't being activated. So it could just be simply dead. Could be an open line fail where it won't send certain output signals or enable lines if another enable is dead, but then that possibly would become present on if we're not getting one of the input lines. Yeah, I don't know. Let's just have a play. No. Yeah, explaining something for me, it's like, well, yeah, I don't know. I do, and I don't. I start to get a little bit fun puddled when I'm trying to explain certain bits and pieces. I still don't like sounding my own voice when I'm sat here talking to myself. God damn. Right, we was looking at... No, we're not going to look at that. We're not going to look at that. We're not going to look at R5T31 because it's an output. Although, is it possible that the system on chip reset, I'm assuming that's reset, RST, is it possible that if that's staying high, or should it go low, or should it go high, or what should it do? So let's have a look. Anyway, obviously if the system is high already, then it may be that it should go low when we attempt to turn on. It might not, I don't know. R5T31, let's just roll it out while we are here. R5T31 should be kicking around in a similar spot. R5T31. I see nothing. No, nothing. If I switch you over, it needs power, good signals before it fires up. Yeah. Yes, Prolux Electronics, I agree. Mr. Bridger and VSB 1.8 and VK1C1P8 auxiliary, there many sub voltage rails. Page 57 to 51 look interesting, all standby. Page page 57 to 51. Page 51 to 57. Yeah, we could argue that we're getting, so U4C3 is on the other side. Is it? Yeah, it is U4C3. So let me just grab that. Let's go over this a little minute. So let me just unlock that. On okay, page 50, page 52, page 52 onwards. So not including 51, no. Let's see, VREG's still VREG in it, so we'll go from this. So let's say 5 volt. This is a 5 volt step down converter U4C3. Yeah, which is P8757, which is up by the Wi-Fi socket. But and I'm say but. I'ma say but, cause I can. So, here's why I'ma say but. If, not if, no buts. I think both Wayne and I went through a little bit on that voltage, standby voltage check sheet that somebody from Game Console Repair Legion on Facebook did. Many thanks for that, by the way. Has fixed quite a few without it, but we typically wouldn't see I'll rephrase that. U4C3, it's one of the voltage regulators. I'm assuming regs is what it stands for. You repaired the trace under the APU. Traces under the APU. What traces under the APU? What traces? Indeed, what traces? I wasn't aware there was any faulty. Wasn't aware there was any faulty traces. Where do you say? Have you repaired? Traces under the APU. Under the APU. So, back on with the voltage check section. Let me just see if I can see where Wayne is meaning. I'm assuming you mean where any prying of the incorrect way on the APU bracket would occur. CPU X clamp, they look interesting. Is that all it's going to be? No, I can't see it. No. I can't see it being that. I can't see it. But let's have a quick look. And where does that one go to? Third in. We can jump on there. Where do we go to? And we can jump on there. So let's dive on to that one and that one. While you're there, do two more. Nah, I did them, just not very well. You did what, mate? What did you do? Where am I? I think it was that one. What is that one? And that test point there don't look cracking, but I don't think it'd be I don't think that'd be a problem. let me just turn that off and disconnect power. And then we are going to there. That's fine. So that trace is fine. I just didn't do a very good job. I ran the traces. Let me see. Let me see. Mate, what did you run them with? There's no trace repair there in that area. But we know what that one's alright, and that one's, I'm going to say that one's the deeper scratch from them both. But there's no, I took them off. Right. We can go from there to let's make our own. Show me a little bit of copper. That will do. That one is fine. And then just to be on the safe side, we then want that one there, or we can go there. Got to make another point. You watch me do it. Oh, Chris, I did it. Did a shit job. Excuse the S word. Did a sugar show of a job. Took off. Was going to do it properly. Gave up and handed to you to do it properly. You watch me do it, man. Now, test them across each other. I'm sure one was running onto the other. No, they're not. They're not running onto other, mate. They're not. And some of these lines will run alongside. As in, some of them will be joined. Some, like the NB car on Xbox One X, does run to each other. But let's just test that one, and that one, yeah, is linked. That one, yeah, is linked. Ground, yeah, it's going to be low ohms because it might be for NB car, so it might be for Northbridge, it could be for GFX, it could be either any which way but loose. So besides that, I'm gonna say they're not broken. Am I gonna say they're not broken? Am I going to say they're not broken? Am I going to say, I know I'm clueless, but not that bad. I will add this. Oh, no. We know it won't. Your damage, mate. Right, so hear me out, because I genuinely don't know if those tracers are working but damaged. Is there something on them that could be suffering from a voltage drop of some sort? Can they be working and weak? So I'm gonna say this. Right. Let's say, without finding where they may be, let's say they might run to a same point. There might be a 0 ohm resistor between. So let's say that one there, this third one in, away from the ground point and the hole for the X clamp bits threaded in what? Yep, clamp. What the bit? Yep, thingy bob. So let's say that this is cut through just on this point here, yeah. But they are all linked somehow individually. So this is nice and clean, no signs of any cut through or any scratches, but yet this one here is got a nice deep scratch, possibly being cut through. Because this one is nice and clean and this is linked to this and that, then typically, yeah, we go from this side to this side, we could generally still get a reading of it, the trace being good. What lines are they? You wouldn't necessarily know if they run to Southbridge without following them. I mean, you've got the skebs are there, so let's take wrong way. Let's take this for instance. What's that? What we got there? We've got DB2R1. So DB2R1 we can throw on the schematics and we can go DB2R1, what it? DB2R1, yeah, DB2R1, which is here. We can, it's only found one of one, which it's only going to find one of one. It don't matter how many times you look at that, because it's a test point type thing. It will only find one, because there's only one test point. So it runs to the APU, which we know about. It was going to run under the APU anyway. But then we can take that's on the same line as this test point. Yeah, and then we can search that line and we find one of two. Let's just quickly make sure they're not on the same chuffing page. They're not on the same page. Then we can go next, and then we pop under U9C2. So we pop up on U9C2, which is the NCP 4205. And it's for the CPU core, which is a input. It's an input running into the pulse width modulator on pin 13. Kill it with fire at this point. Why kill it with fire at this point, mate? Why? Explain. Explain to me. So so going back to the question that Wayne asked on, can they be working on weak? Yes and no. It's we can check on pin 13 and we can see if we get anything coming through, although VDD is no, it can't be. I know one of the V is a they are all separate lines, separate sense lines to tell NCP to turn Northbridge, GFX and CPU core power rails on by the looks of it. Yeah, they're all going to be low impedance though. So going back to what was what, should they all show a low impedance to one another? That's the question. But at this point, it doesn't necessarily mean that it's dead. It can't. We can't roll that out just yet. Again, it depends on how much time you want to put in it. But let's just have a quick squiz at that. Let's just have a quick gander. We'll throw power back in. We'll drop it to voltage mode. We're looking at pin 13 of the... So NCP would be the next logical step to look at, would it not? Not necessarily. I've changed NCP 4205, mate. Not today, but I've changed it. Granted, the NCP 4205 that I put on, if it was a donor NCP 4205, I don't have any new. So if it were a donor, then essentially it's the self and same problem that you've got, which was mentioned right at the beginning. If using donor, unless you can be sure that that donor board was fully working before it become a donor board, then there's no guarantees that the part you're not removing isn't a faulty part. There's no, you know, if that makes sense. But let's drop down on to here. NCP 4205, I think it's an 11-sided chip, is it? A 44 pin? 44 pin, which would be 11 22, which would put 13 as the next, as the second one in. I think it's an 11 pin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, I was right. So that'd be 12 and 13 goes off to there. So we are on 13. Let me adjust slightly so the red probe isn't obstructing the red meter. Let's give it some power, and we do get some kind of signal to begin with. Let's do this one-handed without slipping off that pin. We get nothing anyway. But maybe I don't know, I'm clueless. This is why I watch you learning. Yeah, I wouldn't necessarily say you're learning from me, mate. I wouldn't necessarily go that far. So is that line going to NCP or out of it? It is going to NCP. It is a input, mate, as it states here in input. It's going in on that pin, so check the other end or the other side of potential break. Yeah, could do, but heat NCP up, then try power it on. Why? Right, so something between start and end is wrong. No, not necessarily. Not necessarily, because now we see, because that line was visibly scratched, doesn't necessarily mean it was or has been cut through, but now that becomes more focal point. Although we're not necessarily, if so if that goes to Southbridge, where did it go? No, it don't go to Southbridge, does it? Because there were only two, weren't there? So one was where was it? There. So that's an output line. So in hindsight, that's not forced. That's not forced to be active. Right. That's not forced to be active until the system has been turned on, and let's say it's got on. It's been on for at least 2 seconds or maybe a second, given it that this will be power on, power off within milliseconds, I'm assuming. But let's say that line doesn't necessarily go active until the system is up and running. It's a sense, it's a sense line And all three of them are probably, as Ross said, one will be GFX sense, one will be Northbridge sense, and one will be core sense. One will be bite, as it states there. Although, will it be? Because did we not have three? Were there not 3 test points on the underside? But there's still no saying that these should be active instantly, as in like straight away. We could look at power OK signal for system on chip. Did we look at that on one of others? But now we've gone to concentrating on the CPU, on the APU. So now we're automatically assuming that the APU is at fault. It might not be what's at fault. Everything else might not kick in until the Southbridge has its enablement, if that's even a word, turned on. So essentially Southbridge isn't turning on, Southbridge isn't booting. We're not getting any, there's nothing trying. You know, I get that, mate. We could maybe, depending on how far they go down, we could cut one of them out. We could do to go the right way. See, I must admit, two of them, I do have to admit that two of them do look pretty bad. If I put that into better thing there, they go all the way down like the. So we can do that. Wayne might have a fair point. I must have overlooked them, or at least I can't remember ever. I can't remember, you know, that part. We can go there, and we can go. To there, then we'll stagger this one. Ain't really gonna hurt anything. We'll go there, and we'll go. That don't look cracking there. We'll go there. Unless time ends, Wayne. Unless time ends. The power on, power off 1S I had was NCP. If you heat it up, 350 degrees, then remove heat, and yeah, I don't think it's power on, power off on this one, mate. That's solder. It may be solder, mate. It may be. Let's just squeeze some of that down. Squeeze some of that down there. Change temp on that. Less heat for tinning. No, maybe it is. I put it there. Looks like a hole right about the solder. Yeah, they did look. They did look somewhat a bit off, mate. Let's tin that. Let's tin that. Let's tin that and tin that. Let's fetch wire in. In fact, let's make it a little bit more comfier for me. Let's see if reducing that will make it any better for you. No, it won't. That's a shame. I did hope it would. How long are we talking actually? Let's go. Dee. Let's pin that to there. Let's pull some tweezers in. You don't want to buy. No, not fixed yet. Not fixed yet. Not fixed yet. Not fixed yet. Still not having a good time with this either. Welcome back, David. Are you not sticking because you... Right, you're there. You're still not gone, mate. Quick clean up, lucky flux. I'd probably have been better off just... Yeah, I didn't think it had it. And you're thinking it, I know what you're thinking. You're thinking, why did you not just go to test point? And make it look much bigger. So at this point, I'm not overly bothered of how you look. Oh, that's not my car alarm going off. How can go on there? Do I have a test point on this one? Yes, I do indeed. How can go to there? Plenty more flux down. Why I didn't go to test points in the first place, I'll never know. Right, so we were saying them two, yeah? We're saying them two. Right. Screw the clean off for now. Let's just make sure none of them are. And they're not. I don't think it's them though. I don't think it's them. Let's bob that there. Let's bob that on there. Let's grab that. Can't see it being that. Might be. Nope. No. So it ain't them. Well, I wouldn't necessarily say they're right. But we know they're not Brock. We know they're not split. Such a sausage fest in here. It's full of all gents in it. Right, so we know it's not that. So we can roll that out. So we let's start back to this. So as I was saying, remember now, it's got to be something to do with Southbridge. If it wasn't something to do with Southbridge, have you tried to artificially send the enable voltage? You mean send the enable voltage that we're missing? We're missing several, mate. Which is why we've come to the conclusion that the Southbridge IC either isn't enabling or it's ghost. No, there's multiple, mate, so we don't get that one. That one there we don't get. If you're looking on your phone, you might not be able to see where that's pointing out. So it's not sending that out. Can't remember if it was sending anything else out, or in. But I mean, we can check these. So we can check voltage regulator power good PB, which is an in, and then we can check that one there, which is an in, which would be DB9F14. F is going to be top side. DB pin 21 on SMC power good pin 21. No, need to check when you say pin 21 on SMC's BGA, mate. you didn't mean that 21, did you? Because it's going to be... So the way yeah, it'd be hard to find it underneath. So ideally we need to ideally go for test points or areas further down the list. So look in page 53 and 49. Yeah, that's what I mean, mate. So we can either go that, we can either hunt for that test point, DB5 F2, or we can go for 49, page 49. I just like to keep things slightly simplified. So we're going to go for that. Then we'll jump to page 49, and this is an out from U5F3. U5F3, which is the U5F3, which is I do not know. U5F3, can't be hard to find a U5F3, can it? It should be in location 5, should it not? Oh yeah, of course. Becking. No, see, I've done it. Too late. Too late, I've sworn. Right, so U5F3, we're looking at pin 15, which is P good, which is for NB car. So we are looking at, let me brighten the place up. We are looking at this. And I should have realised sooner because of the number 3819. But oh well, never mind. So, power back in. Just in case. Front panel back on. Ground pin out, and we want pin 15, which I'm assuming would be that one, just there. So we get, it boats, we get a power good signal from there. When we attempt to boot. So we're getting power good from there. We can then fly over to the next. U5F5. And that's an output 2. U5F5, which will be the one next to it, I'm assuming. which will be that one there. Which we've changed these anyway, haven't we? That's pin 9. So it'll be that one there, which happens to be exactly where the test point is, DB5F2. You can't see. God damn it. And we get a temp of power good from that as well. So that power good will be reaching Southbridge. N22 and R22 on SMC are another power good. Are you sat with, are you sat reading thing, mate? Yeah. So my guessing is we're going to get we're going to get 5 volt in. So 51, 51, 51, and we want I like it, mate, I like it. 51, we want 5 volt power good out, 5 volt power good out, 5 volt power good out, which is part of power good line anyway. And we can check on resistor R6R1. R6R1, I'm almost certain, is on the underside. R6R1. Which indeed we are. Sit that there. Change screen. I'm thinking at this moment in time, an investment on a one of them, what do I call them? Stream Dobry Firkin. Thingamabob. Wayne's got one. R6R1. R6R1. We can check if we get power good from R6R1. We get 5 volts out that side. We get 5 volts out that side. It's a 1 kilo ohm. So yeah, we're gonna be getting that. That's gonna be going out to Southbridge, which is there. That resistor there, I checked. So back to page 26, and it was, what was the other one? R22. R22. We only have one input, but we can check on now. We can't. I'm not checking there. Let's see, page 50. Page 50, and we want power good P8, I think it is, isn't it? Yeah, power good P8. Power good P8. U9 F1. And we're there on pin 20. Power good PA. Yes, Ross. See you later, mate. Have a good one. Flicky board back over. And we want 51916. And we want pin 20 of the 51916, which is there. We don't have to look for 51916. It's a 20 pin chip, so it can only be 1 point, which be that one just there. And again, that tries to 10 volts. But again, 51916 has been changed. Five 1916 has been changed. So back to the drawing board. See, me personally, I'd go down route that because it's attempting to power on. So because it's a power on off, then I'd go down route as to say that the power good signals are there. U22 is that's a power good PC enable. Oh no, that's an out, not an innie. An outie, not an innie. VREG 3.3 enable, that's an in. Did we look at that one already? I can't remember. Give me 30 next. No. U42, so that's that, and that's still part of power, so that's on R5, R6. Did we look at R5, R6? And R5, R7. R5, R6 is going to be on backside. This is the only letdown, is flipping the board over every pair of plates. R5, R6. So we want location. Location. R5, R6. R5, R6, which should be somewhere over here. Out. R5, R6, there we go. So we are there. We know that it meets R5, R7. on that line, so we should be able to go between those two. And go there. And indeed it tries to do something. 6 volts, so I'm assuming by the time that's settled down it'll settle down to 3 volts. So that is there. Well then, there was another one there. Yes, of course there was. Right. So there's 2 of them. And there's that one. That goes to U5D4. And it goes to the enable line. That's an in though. That's an in. U5D4, U5D4. Let's just check that anyway. Because it could be that it's getting to U5, which is U5D4. U5D4 is that one there. And it goes to pin 1. Oh, there's also a test point. U5D4. Pin 1, pin 1, pin 1. Which would be that, so that'll be the test point. Do we have a resistor missing from there? Should R5D8 be on board? R5D8, no. It states it's empty. I can go from there. I'm going to start swearing there. Yeah, so we're getting 10 volt. It's showing 10 volt from there. Which is possible, I guess, because that then goes off to... No, that's empty, so it can't. So why would we be getting an higher voltage on that there? When it doesn't. I'm back to previous. Which is there. No, can't do that. I'll have to zoom in. 6R5, will that R6R5? No, it won't. R6R5's on the other side. So we're getting some kind of enable from and to them. Not quite sure if it's direct. Direct, but that was a... Yeah, that one in. that's an in. So that only shows it there. No, of course. So we went on test point. So test point then must go to no, because it's not showing any test point there, is it? No, oh, you can't even see. It's not showing any test point there. Should be 5 volt in and 3.3 volt enable. How does that work? Pin 1 and 3. 5 volt in on. It's 100 kiloohm though, isn't it? I mean, it's saying that it showed it. Right, so it doesn't necessarily mean that that line should be 3.3 volts on that enable. All that means is it just means that that's an enable line. So the voltage that we see on pin 1 could be a similar 5 volt, just a 5 volt enable signal, which would explain why my meter threw it up as 10 volts, owing to the fact that my meter tends to double before it settles back down. So in hindsight, it must be a switched line that isn't going live until that does. But are we seeing 5 volts on voltage in? I'm assuming we will be seeing 5 volts on voltage in, which what, pin 3, which would be that one there. How about checking pin 4 for 3.3? That would determine U5 D4 should be working. Pin 4. Yeah, on a switch, yeah. Pin 4, which is going to be that one, which will be that test point anyway. So we can go to that, power on, and we get 3.7 volts. So that is got to be working, but that's an in signal anyway, and it's an in signal on Southbridge, so like I say, I'm tipping that majority of these are going to be there. Saw 3.4, so that's good. Another one knocked off the list. Who's keeping track at least? That's the question. We could end up going over them again, and how devastating would that be? So we've done that one, right? We've done that one. We've done that one. That one. We've done that one. Did we do them? I think we did them, didn't we? DB5 F2, DB5 F2. Yeah, we did them. They came off. DB5F2 were down by U5F5. And then I think that one there came from I can't remember. I'm sure we've done that one now. Which one in? That one was 50. Let's just check. Let's just make sure. Sure we've done it. 50 and it's power good PA, power good PA, U9F1. Yeah, 51916. Yeah, pin 20. Pin 20. Yeah, so we did that one. Did that one. So we want the next in line. Let's start from the top. On the right hand side, next one is VREG CPU, power good, GFX, Control C, let's Control B. This is likely to take us over by NCP 4205 at some point. We want page 44. And that's an out, and it's NCP 4205. NCP 4205. And it's pin 6, 2, 4, 6 is that one there, which goes up to there. Now here's the thing. Is the thing. It does try. It does try and throw a signal out. So we know that one's good. Next one. Next one is on the same, and it's pin 11. Pin 11, R9C26, resistor 9. R9C26, R9, which would be that one. So R9C26, it isn't going to be, chip side, it's going to be the opposite side. Which would be there, which we do see. But do we see anything on the opposite side? What 0 ohm, so we should, yeah? Of course. Yeah, so we see that. On to the next, which is an out. Again, that's on pin 7 of the NCP 4205. Pin 7 would be that one there. I think there's some of these that one of these that's linked in it. Yeah, we see that there. On with the next is connections, switches, which is an in, and that's for debugging, and that Q9 C4, which isn't likely to be in on the board. Q9 C4, Q9 C4, C4. Oh, it might be on board. Q9. C4, we want C4. So no, it ain't gonna be on board, is it? We're in C4. I don't see any print for a Q9. Or did we need to be further over? Oh, of course we need to be further over. We need to be right over there, don't we? No, I'm starting to not think now. Q9 C4, Q9. Q9 D, Q9 C4. We're not on board. It's empty. It's there. So we're not going to be on that one. So we head back off to the South Bridge. I keep forgetting to switch your over. So that was the one that we've just looked at there, which isn't in. Cold reset. Is also an in. Do we look at cold reset? On page 67. Cold reset then goes off to 3.3 volts standby. It should be R5G1. R5G1. Which is there. R5G1, R5G1, scope count, R5G1. So one side it should be, might be 3.3, or both sides actually. Yeah, 3.3. Go off that, yeah, 3.3. So that's alright, we only see that in one place as well. No, actually, should we check it? Page 67. Let's have a look. Page 67, and it was, what was it? Cold reset, wasn't it? Cold reset, warm reset, cold reset there. Yeah, that's just where that switching double faking is warm or not. So it ain't gonna be that. Oh. My guess is we are getting ODD wake. I'm not sure we're gonna see ODD wake. However, if I've got a disk drive to hand, and I'm not frankly bothered if it's the correct. Let's knock that off. Let's go that to there and that into there. Let's just rest that there. Let's take out a disk. Give power back. So we don't actually have it attempt to boot from a disk. What if the SMC isn't getting any clock signal on pin 1? See page 29. What if the SMC isn't getting any clock signal on pin 1? See, this is where the issue lies. I may not see a clock signal, because a clock signal is going to be frequency, isn't it? Page 29. Page 29. Pin 1 now. I know you say pin 1. Pin 1. Pin 1. That would stop it from turning on. Smelloscope time. Yeah. Clock would. Definitely. It's like removing the BIOS clock, in it. That's what it's like. Removing it out of a PC system. It won't. I don't think it'll boot, will it? Without a PC system. But where did you point out where you meant by pin 1, mate? On page 29? Or what did you mean pin 1 on the other side? Because these because it's BGA, it's the grid references and the pins are chuffing horrible. Obviously, D16's a pad, F20 is a pad, D20, E20, D21, so on and so forth. And I think it goes A1. Does it go A1, A2, A3, A4? Possibly not. Sorry, pin 1 on the SMC. I see. Pin 1 SMC. Where pin comes in from page 29. Pin 1, pin 1. So you mean PEX ref clock? Is that what you mean? You mean in that line? Do you mean that line? So let's knock that off. Let's unplug that. We're not getting any boot. We're not getting any boot. We're not. It's not attempting to boot from a disc, from putting a disc in. So it could be somewhat online of an ODD fault. Let's have a look. So if it's that line, this is where I can't determine the names now. No idea what PEX. PEX, I think, it's similar to do with PCs, isn't it? I think you get PEX, you get like a PEX signal on PCs. I think it's part of the boot, but I think PEX is one of the last to boot, is it? But let's see that's where probably for clock signals where a smelly scope would come in handy, mate. But we've R4B3, so resistor 4 in sector B3. Right, R4B3, let's have a look. Yeah, shall I answer? Yeah, go on. Let's see. Hello? Hello? Sorry? Yeah, see ya. Can't believe I didn't have that on loudspeaker to begin with. Right, so, and then a bit time I put it on loudspeaker, you don't phone it. Scamming twats. R4B3, R4B3 is R4B3 is that one just there. That one there, we're gonna say R4B3. We get some voltage there. It's gonna be a 0 ohm. It's a 0 ohm. It then goes on to R4B10, which is empty, and R4C26, which is empty. So that's nice of them, isn't it? But there's a second one on that. Which is on opposite side. There's a clock 1 and a clock 2. There's shitloads of clocks. But I guess a clock signal would stop it from booting. But it doesn't say whether that's an in or an out. So unless that's internal. Unless that's internal. So we've got now, so we've got this on C19. But it doesn't state whether it's an in signal or an out signal. A bit like that one there, which is 12 volt gated. Also doesn't state in or out, but with 12 volt power good signal going out. Which is going to be there anyway. Because if it wasn't there, then it wouldn't allow 5 volt to boot. Nor 3.3 volt to boot. I don't think. Would it? Am I just talking to myself? Am I just thinking out loud? What's that? F. Oh, no, zoom in. Hang on, my glasses on. Page 53. Page 53. Page 53 comes in at U5, F5, U5, F5. Or does it? No. It's there. It's there, U5D3, U5D3. AF22 goes to SMC RST. SMC reset line. Reset line. So. What page were we on? What page were we on? This is the other problem. We'd moved off of the thing with page 29. We were on page 29, weren't we? Page 29. Yeah, we were there. Page 29. Right. AF22 goes to SMC. Yeah. R4E30. Is that a typo? R4E30. E3, R4. No, it isn't a typo, but I can't see it yet. R4. R4E30 is the bottom one of that. Right. R4030 is R4030 is the bottom one of that, which is what it states there. R4, yes. So R4030 would be that, which we get 3.2, and that's a constant 3.2 anyway. Now the question is then, it's going to be 3.2 on the other side. So the question is if that's a reset line, should that go low or should it stay high? Should it go low or should it stay high? Then you have a clock monitor, Southbridge clock monitor. Ooh, remove it. Yeah, could do. Why not? Try it. I can't see it making much difference though. Well, when I say let's just slide it along. Has that chip got a chunk missing from the corner? No, it's not got a chunk missing from the corner, mate. All four corners should more or less be the same, barring that one. So pretty much all the other three corners are identical, mate. It's think it's where they come off the manufacturing process side of it. Right, so this isn't gonna have done nothing. It's out to what's the term? It's out to annoy me, innit? Wait. That's an out signal. That's an out signal, ain't it? So it could be. It might be meant to go low. Let's get some juice. Let's check that side of that now. Now we get 0.3. Now we get fluctuation of 0.5. No, she's a no power at all now. She's no power. So she needs that. She needs it. Do 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 do. So U4D2 is assumed okay then. No. No. No, 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 no. No, 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 no. Because we're still not getting some of us outgoing out enable signals to other components. It does have a ton of signal for other stuff. Yeah, it's not necessarily totally dead, mate. Yeah, it could simply be. Well, it can't simply be one signal line, can it? Because we don't get quite a few. We don't get quite a few of these, do we? We got that. I think we got that. We got that. We didn't get that, but we're not going to get that anyway. Because there's no... Because there's no HDMI in. So we're not going to get that anyway. Wi-Fi reset, no idea. I'm assuming that's Ethernet LP mode, don't know what LP mode is. Stick a tone generator through it and trace signal. I don't have a tone generator, mate, and I won't know what the fudge to do with one either. Fan power management, that's an output. Don't know if we get fan power management. TDO, Steve B mentioned that will be for the JTAG and the debugging. So I don't know. I do not know. Do we call it completely dead? See, I don't really want to call it completely dead. I'm not even, at this stage, it doesn't even matter if the board is repaired. What matters is finding out what's gone wrong. Yeah, but then there's no... If I just swap it, then there's no saying that there's no explanation as to what part of it failed. We don't have any attempt. It doesn't make any attempt to wake up by a disk using the thing, and this is definitely not an all digital model. So we could follow route of. No, we don't have to follow route of. Do we have to follow route of? ODD. ODD open. ODD wake. So I'm assuming ODD wake would be if we tried to put a disk in. Frustrating this is there is no output from the SMC. Yeah, that's what's frustrating, mate. But there is certain outputs. There's got to be certain outputs. Because the likes of the 5 volt power good signal will come back in. So in hindsight, the south bridge will enable the 5 volt step down converter, and then the 5 volt regulator whatever power good signal will come back into Southbridge. So it's almost like a loop. SMC F1 thermal trip could be bad resistor. SMC thermal trip, where's SMC thermal trip? SMC thermal trip, oh, do you mean SOC thermal trip? SMC F1, yeah, so SOC thermal trip, yeah. R5T27, that's opposite side of the board. what were we? R5T27. R5T27. Which is there. R5T27. Which is right by my thumb. Looks like it loops back in at J21 on SMC. J21 on SMC. On our 5T38. On our 5T38, which is empty, so R5T38 is empty, so R5T27 on, there should be a 0 ohm link, R5T27. And we are indeed a 0 ohm link, but then that goes off. Yeah, it goes off to that and comes through there. So yeah, it possibly does loop back through. Yeah. Although there's something there as well on page 8. Which page 8 is? Page 8 is. Trip. Of course, page 8 is going to be that, isn't it? Why wouldn't it be? Which then also comes from the APU. Page 8 is going to be APU. So K22 SP SMC in INT, would that be initialized? Desktop K22. Yeah, that's gonna be from is it gonna be from there? Because that's page 8 again, which is APU. And it says, and it shows page 26 again. So does it pop up somewhere else on here, on page 26? I don't think it does it? Bit presumptuous to reinstall it. The two above it as well, J22 and H21. Yeah, well, I think we see sock power out, don't we? Did I test that? Yeah, I'm sure I tested that. No, we didn't get that, did we? We didn't get that. We didn't get that. We didn't get that. That K22 TD. Oh, which will be TD. Don't know. That TDO. I think Steve B mentioned that that'd be for the thing, but possibly not. However, resistor R5T40, that's empty, so there's nothing on the board for that. And it's a straight through, so that's going to be, it's going to be, that won't particularly receive a signal on that one there, SMC. Yo, screen protector, which was learning electronic repairs, was it not? I think memory serves me correct. Roll on Wednesday. Screen high. Why roll on Wednesday, mate? Is it because it's today's over with? Yeah. Good. So R5T29. Can't remember if I tested R5T29 or not, which is an out. I don't think we got. I'm sure. I'm sure R5T29 was tested. I've just got to find it again. R5T26, you'd think it'd be over by R5T26 somewhere, wouldn't you? R5T28. Is that, or is that R5T26? Where the bleeding out are you? I'm sure. I remember saying I'm sure. While we're there, we'll test R5T31. Leads over to pin 44 of NCP 4205. Pin 44. What does make the H21 the power OK? Trying our best. Oh, trying our best. Yeah. Although I do have one rebound ready. I prefer to find this R5T29. Because then we can go direct from the R5T27's there, which means that we're only two off. R5T29 there. R5T29 is That one there, yeah. And then R5T31, what other one, wasn't it? Yeah. Yeah. R5T29. It's right there, see, staring me in the face. R5T31 is that bottom one, and R5T29 is that one just there, which I am certain we tested, which was that one there, because I've entered them. I went in there and we get nothing. We're not going to get anything, are we, because I've unplugged it anyway. See, brain's starting to shut down. And now I've lost it in. See, that capacitor there don't look very clever either. Some of them, there's quite a few bits on this that don't look right. That don't look right good. Right, we're back here. R5 T29 is that one there. You would have to have one first, right? Oh, standby volts. Yes, all standby voltages are present and correct, mate. So we get nothing on that. So we're not. We get diddly squat. We're in fucking homes, man. Now I'm swearing, see. But yeah, we get nothing on either of them, and then the other one was that one there, and we get nothing on that, and nothing on that side. So we get no. We're getting no. System on chip power okay either, but that is an out from the SMC, from the Southbridge. Have you tried to disable some power rails? No, mate. You would have to have one first, right? What? I have one what, mate? Have one what? The problem is because one can cause that. One. It doesn't have to be short to ground. Oh no, it can be. It could have failed open, yeah, mate. Or it could be a power line being pulled down slightly. Missed that be. So sock power, you got nothing at that resistor. No, so we don't have anything on R5T29, and we don't have anything on R5T31, which are both outputs. So obviously Southbridge at some point, SMC, isn't sending these out. SP, SMC. So what's SP, SMC, INT? Would that be initializing? R5T20, R5T42. Brain, yeah. Yeah, mate, I ain't got one of them either. Screen protector, go away. I know, mate, I've not got one. But we've got no schematic. Oscilloscope could help, but we've got no schematics. No schematics for what? Right, R5T42. Last attempt, then call it a day. 6:45. We've gone 4 hours 41 minutes into a live stream, and we've got absolutely nowhere. It would have took me the whole of 20 minutes to 30 minutes max to swap out salvage. R5, what did I say? R5T42, R5T42, R5T42. But we don't do it like that now, do we? R5T42. Wow. Comes. Wow. Yeah, I won't meaning go away, mate. I was just meaning a oscilloscope, a smelly scope. Be nice, but yeah, I don't got one, mate. I don't got one. So R5 T42, R5T42, like a MacBook, SMT and JTAG go hand in hand. Right, will we see out from this? Yeah, we're getting voltage there anyway. We're getting voltage there anyway, so that's 0 ohm. That's that 0 ohm resistor is fine and dandy. And that is J5 on SMC P2 GP in out 1. I'm assuming. No, I have no idea. No idea. Yeah, I don't know. It might be a jump back on tomorrow, swap that and see what happens, and then I don't know, would it be easy enough to, if it runs, would it be easy enough to diagnose? But we're not getting any attempt to boot. We're not getting any attempt to boot from a disk drive, from entering a disk, putting a disk in. So she's not waking up from doing it like that. Obviously she'll want to wake up, or she'll attempt to wake up from pressing the eject button. Don't think there was a disk in this drive. drop that out a bit. Put that there. Let's turn power off. Let's see that in there. Let's see that on there. Let's make sure we are fully plugged in, which we are. Get some willy. Fill that up there. Right, there's no disc in. We have power to the disk drive, I'm assuming. Do we? No, we might not have. We might not have no power to disk drive, you know. That's definitely not wanting to boot. So, that's in charge of power, right? Which was ODD wake was page 40. ODD wake was page 40. ODD wake there, which is pin 1, which is an out, which goes through R5 C10, which should be on 3.3 standby line, which is interesting. Is it no? 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 That one there's a no connect. So do we not have no voltage there? We don't got no voltage there, do we? Pin 6, 3.3 volt standby pulse, and then pin 12, 10 and so 12 and 10 should be 12 volts standby. Nope, not standby. 12 volts. So I've got it. See, I need sleep now. I need sleep. Right, let's try that again. 3.3 volts. 2.9 volts. Should it be 2.9 volts? That should be 12 volts when we power it on. Right, so that should be 12 volts. No, wrong one, idiot. That's ground. That should be 12 volts when we power it on. But it ain't, we're not getting no anyway. Are we? It don't matter which side with that we got to. Danny! I know, mate. What can I say? Is that what it's going to be? Pin 2's a no connect. Right. Pin 1 starts there, so that's pin 1. So, pin 1, pin 1, pin 1. Watch. Yes. Scope cam. Right. So, pin 1. Pin 1 should be 3.3, well, goes off to 3.3 volts standby through a resistor which is R5C10, which is just down here. So is that side's 3.2, and the other side will be what we've been seeing then at 2.9. So 2.9 on there. So pin 2, pin 12 is there, it's numbered anyway. Phoenix, welcome mate, welcome. Yes, we've been viewing the schematics, mate. I might want to watch it back. So pin 12, it states, is 12 volts, which is an in. Yeah? So we should see 12 volts there when we attempt to vote. We see no voltage on there. That is 10 volts also. Pin 10, which we're going to see no voltage because it's linked. This is 5 volts. And we see no 5 volts either. It's 1S board, mate. Pin 6, which is that, should be 3.3 volt standby pulse. Any of them lines have a short to ground? Not sure, mate. I'll check in a second. We get that attempts to go to 3.2 volts, maybe, when we attempt to power on, but it's set at 0.8. And pin 4 is ODD status. We're not forced to see any. We're not forced to see anything on there. Any shorts to ground on that. Let's unplug that. Let's check in continuity mode. Pin 12, no. Pin 10, no. Well, pin 10 should be directly linked with pin 12 anyway. Yeah, so pin 12 is directly linked with pin 10 anyway. Pin 8, no, which is 5 volts, and pin 6, which is the 3.3 volts, no. Pin 1, no. Pin 3 is ODD open, I'm assuming, so that'll eject when you tell it to through the switch or through the dashboard via Southbridge. So There's no 12 volt at the disconnector. That wasn't my multimeter, mate. That what console. No, Lee, none of them have short to ground. But at the same time, Southbridge. No. The thing is it doesn't say that it's 12 volt constant. So I'm assuming that must be a 12 volt switched. So if that's a 12 volt and a 5 volt switched, Southbridge should send an enable signal to this, I think. Let's quickly grab a look at that. What is that? That is U4C1. 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 Yeah, that was that Minecraft doorbell, mate. So you've got a Minecraft doorbell. Right, so we go through a series of FETs. 12 volt point on R4C12, R4C12. 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 Helps if you put power to it as well, Chris. Just so you know. And turn it on. Just so you know. Did I tell you I need sleep? Right. So we have 12 volts at one side of that resistor that should be 34.8 kiloohms. Why have they got to be said? Why not go 35? Why 34.8? So we have 12 volts at this side. We have diddly squat at this side. Would 34.8 kiloohms kill 12 volts? Yeah, definitely not there. Definitely nothing there. And just to be sure it's not being caused by the optical disk drive, we can go back there. And there's no there. Mike dying. I don't know, mate. I hope not. Oh, fuel cutouts. Possibly, mate. I don't know how long these batteries will run, but it's going to be D'ing soon, is it? Right, so 30, what was it? 34.8 kiloohms, it reckons. What we got on that resistor? What we got on that resistor? No, we've got 34.8 kiloohms on that resistor. No? No. 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 So how is that possible then? So tell me how that is possible. How is it out? Unless the LM339 is dead, kaput. But I can't see that, can you? No, I can't see that. I can't see that. ODD power enable. No, I'm going to call it a day. Am I going to call it a day? Right, so let's recap right quick. Because if I call it a day, then I can watch last 10 minutes. Last 10 minutes and realise where I was. Goddamn machines. 7:05 and all. 7:05, gents. No, it ain't, Danny. Not till past, mate. They've moved it to past now. Am I so sad for knowing that shit? Right, so it states here. No, because how can that not be? That's a resistor. So cat. Cat. Cat 5B15. Cat 5B15. C5B15. C5. C5. B15. C5B15. Where the fudge are you, C5B15? C5B15, C5B16, C5B13, C5B18. C5C14. Okay, my time here at the day job is almost over. Yes, mate. See you later. Have a good one, Travis. Glad I could help you skive, mate. Where the frig is C5? Oh, see, go away. We actually want C5, B16. C5, B16. Which, that is... So none of these go to ground. So that's 5 volt. So that goes through. That goes to the gate of that. Which we get no action. So it looks of it, we're not getting any action on gate on this. That is Q5, B5. Yeah, Q5, B5. So there's no there's nothing on the gate of that. Gate on this is staying low. Right, so I'm calling it a day. Okay. Right. Put that there. Call it a day. We've been at 5 hours. 5 hours, man. 5 hours. Would you say we're any closer? Probably not. Could be something to do with that though. If it's not, if it's looking for a signal back from that somewhere, maybe. Don't know. So I just love listening to your ramblings. I don't like listening to me old mate. Right. Anyway, we're gonna call it a day. Screw it. 5 hours. Might make another appearance on it. If not, might be a short video. Might end up changing that. Maybe not. Might need to look at why that gate's staying low. Sure, that gate shouldn't stay low. Sure, that resistor should go high at some point on that one side. Unless it's because Southbridge might not be enabling that chip. That's a possibility. So we'll leave it at that. We've tested all ins, have we, on the Southbridge. We're getting all information in, are we? We're not getting them all out. Could still be Southbridge. Hopefully not. More than likely so. But it is what it is. And we do what we do. Well, yeah. Might make a reappearance. And if we don't fix it on reappearance, it might get snapped in half. Just to count theirs. So, on that note, let's just call it 5 hours, 10 minutes. Nothing doing, nothing gained, nothing lost. We're still the same. Hello, Philip Bryden. Welcome, mate. Unfortunately, goodbye. Right, as usual, guys, if you didn't enjoy today's episode, please feel free to hit that thumbs down. If you enjoyed me being punished, feel free to hit that like button, that thumbs up. And as always, if you're not subscribed, jump on. Plenty of boring times. If anything, I might put you to sleep on a night. Shame I don't stream on a night, innit? Mid-afternoon nap. Mid-afternoon nap. Right, guys. Till next time, look after yourselves. And we'll see you all later.